What's up, YouTube? MR2 here. Got some little science project set up here, man. Gonna take a look at the electromagnetic current, the static charge in our atmosphere, and how static electricity works, and its effects on our planet, and the fact that they don't have any real explanation for what effects that we can see here that static electricity does actually have on this planet, and they call the difference between gravity, and we're gonna take a look at gravity and electricity and see if we can figure out the difference. Good buddy sitting this here to get well present right here, man. This is pretty awesome. It's a levitating globe, but I just set it up here so we have something pretty to look at, because I ain't all that pretty. At any rate, the Earth itself is, the crust of the Earth is made of 90% sand, silicon, which is glass, which is a highly insulated material. And on the list of static items that'll hold a static charge, rubber, glass, these things are very high on the list. In fact, a balloon, the surface of a balloon is rubber. It acts as a good static charge, or capacitor, whatever. It acts it's actually close to the makeup of our crust. And when you see the amount of electricity that flashes through the clouds and the lightning, you can take a look at some of this footage here. You'll see that we have massive amounts of electrical charge on our planet versus a balloon. But at any rate, we'll take a balloon. I got a bag up here. Let's take one and blow it up so y'all can see, because this ain't nothing trick here, no tricks or nothing here. I mean, anything you see me doing, you can do yourself, and prove it to yourself. Yeah, I know. Y'all can save them comments too. Look at here. You take the balloon, now it's already going to have a static charge as soon as you blow it up. But you can rub it on your shirt, on your hair. And if you rub it on your shirt and listen to it, be quiet, you can hear it start popping and snapping. Those are little arcs of electricity popping between. That's like lightning in the atmosphere of the Earth. And even, at that scale, I would say it's pretty close, because, you got to think a lightning bolt on the planet from way back here. It's just a very little small spark, just like it is right here on my shirt. And you rub it on your shirt till you start hearing that. And the same principle is applied here. The friction is causing static electricity to build up, or catching free electrons from the atmosphere, which always comes from the sun anyway. So and what I'm doing on the outside, the molten inner core of the Earth is doing on the inside. It's doing the same thing, same processes as this, same friction, capturing of the electrons from that, from its source, which is the sun, which is going to supply a source to this balloon and this planet and me and you and everything else. Nonetheless, the static charge it's a magnetism and electricity, and the fact that it has an effect on anything is what's so amazing about it. It's not just metal that it attracts. In fact, we're going to see here. I'll show you through these things we got set up here. Got a piece of cereal, paper clip. If you can see that, then we got a piece of leather strap and a piece of plastic, and this is just a little magnet. It's got a north and south pole on it. Be curious to watch that one. A piece of paper, and here we have a piece of electrical tape. And so we'll take a look at this. Watch what happens when you bring this too close to the piece of cereal. It's going to have an attractive force, and in fact, it's going to try to pull that piece of cereal right over till it touches it. It doesn't matter which side of the balloon use, it's going to stick to it. That doesn't matter what it is. Do it with the, well, we may not even be able to do it with the paper clip because the damn serial is going to get thick. At any rate, you can see that paper clip, it also has an effect. It'll pull it right over to it too. Anywhere around the balloon, it doesn't repel it. And then the second one, we'll take this piece of leather. You'll see, same effect. Doesn't matter what it is, it still attracts it. We'll go to this piece of plastic. You'll see, doesn't matter what it is. It's going to pull it over there. Works better on some than others, but nonetheless, this definitely has its charge to it. They go with the magnet. Of course, you can see that little piece of paper back there. It's just jumping all crazy about the magnet, the paper. I mean, there's nothing here that this doesn't have an effect on. And that includes water. Take a look at this here. And you could do this at home too. You'll see if that water's going to try to dump right out of that sink. It'll go right to that balloon. And I mean, you can hold the balloon down here and ground it to the sink. It's still going to attract it. You know, static charge. If this static charge around this balloon, as weak as it is, will bend water or attract water, make water stick to it, then you know the electrical charge that we see around our planet with the amounts of lightning that we observe and the magnetic field that we observe is much greater on that scale than it is on this one. And to say that water is on that planet because of an inner force rather than an outer force is hard to believe now when you know as above so below. There's not a thing on this planet that's not attracted to that balloon, that static charge. Just like that is the one that's on our planet. And I got this one wet. Go over another one, I'll show you something else. The way these objects will align themselves, I mean, you know, did the magnet have anything to do with the balloon? Everything's attracted to electricity. Everything. There's not a thing here that you can't do this with. We did water. Got some shavings, wood shavings from outside. Some plastic shavings, PVC, wood shavings, whatnot, such as that. This gets charged on this. It's already got it pretty good. Some balloons fresh out of the bag, they got a real good charge on it. Nonetheless, it's the engine that turns that keeps the whole thing going. And ready to put the ticket down here. You can hear it picking up the particles immediately. And what we'll do is take a look at this. Now you notice how whether it's plastic or wood shavings, it don't matter, it sticks right to it. But look at the orientation. Look how everything wants to stand straight up, like a tree, like you and me. Isn't that something else? And the fact that scientists don't, you know, that this scale, we should have some explanation or some sort of scientific explanation for what effects this should have on our planet. And yet we're told it's gravity. That's it. They don't have any other explanation as to why this happens on Earth. You know, the reason they give for this balloon is totally different than the reason they give it for that planet. when in all actuality, as above, so below, they're doing the exact same thing. You know, you can take a magnet. So you don't even want to leave me. You can take a magnet and anything really. You'll see magnetism is much stronger than gravity. There's a tuning fork here, and you know, as we're talking, the Earth right now is pulling down on the fork. If I let go of it, you know, the Earth's pulling down on that right now with all its force and all its might. The Earth's pulling as hard as it can on that tuning fork. Yeah, there's a tiny magnet here. It's strong enough to overcome the whole force of this Earth. Pick that up. Overcome gravity. Billions of times stronger than Earth. Think about that. Think about that scale. Keep that scale in mind. The entire Earth is pulling down on that. This tiny little magnet, which is 100 millions of times smaller, smaller than the planet, yet it has no problem with it. So what we're being told and what we're being learned is obviously not the case. At any rate, I thought that was pretty cool, man. Put that video out. Tell everybody to appreciate it, man. Feeling much better, man. A lot better. Still can't move it over here too fast, but I can do this better, a lot better. I ain't walking my arm, ain't hurt none of that, so it's all good. Still got $1,000 left on the up to $3,000 on the deductible. Hopefully I get the other surgery done before the end of this year. Won't have to pay the other one for next year. But at any rate, whatever you all guys decide to do, just let me know. We can get involved. We just go with the vote deal to whatever I mean folks want to say. We do this with it, and then we'll do it democratically, I guess. At any rate, peace and love, man. Big old heads up. Thanks.